Welcome back viewers. After a break of around 4-5 days, I am back with a new video. In today's video, we will be checking out the Nix package manager and how it works. So Nix is a purely functional package manager. This means that it treats the packages like values in purely functional programming languages such as Haskell. They are built by functions that don't have side effects and they never change after they have been built. Nix stores the packages in the Nix store, and usually the directory /nix/store, where each package has its own subdirectory such as the Nix store. There will be some hexadecimal name, or we can say just a random name will be there. And then we have got this Firefox 33.1. So the Firefox version 33.1 package will be stored in this path that is given. And so different versions of Firefox, when they will be eventually installed, so what happens is your system will continue to get the updates to the Firefox, and each update of the Firefox, each update package will be stored in a different path. So you will have multiple Firefoxes installed on your system, and all those multiple paths will connect to one, we can say, one state of the system, and you can roll back to the older state and you can come back again to the new state. So it will be all depend on you. If you want, you can roll back. If you want, you can use the older configuration of the NixOS. So the older configurations of the NixOS will point to the older paths of the packages, and the newer NixOS configuration will always point to the newer paths of the packages. So like that it works. Identifier for the package that captures all the dependencies. It is a cryptographic hash of the package's build dependency graph. This enables many powerful features. Now you can have multiple features or variants of the packages installed at the same time. This is what I have told you earlier. This is especially important when the different applications have dependencies on the different versions of the same package. It prevents the DLL hell. Because of the hashing scheme, different versions of the package end up in different parts in the Linux store, so they don't interfere with each other. An important consequence of this operation is like upgrading or uninstalling a application that cannot break other applications. Since these operations never destructively update or delete files that are used by other packages. So what it wants to convey is that suppose you have got this Firefox 33.1. Now an update comes, say Firefox 35 version has come. So when you install the Firefox 35, it will not destroy the Firefox 33.1 and its dependencies. The Firefox 33.1 and its dependencies will continue to stay on the system. They won't be deleted, they won't be uninstalled, but they will continue in the system in a different file path, while the Firefox 35 and its dependencies will have a different file path. So it will create a new file path for the newer Firefox 35 and its dependencies. So totally complete file path will be there, plus the configuration of the NixOS will also be different. So the newer installation will have a newer NixOS configuration, and the older application and the dependencies will have older configuration of the NixOS. So you can just select the different configurations of the NixOS from the bootloader itself, and you can continue either in the older or the newer configuration, and you can use the older or the newer application packages and its dependencies. So here the upgrading or uninstalling an application cannot break other applications. So this ensures that you can see you can use older, newer packages and the dependencies, but they will not interfere with each other and break the dependencies. So your system is stable, it is usable. You can have a choice to use the older packages or the newer packages because they belong or they are installed in a different file paths. When you are making a package for a package management system, for example RPM, you are supposed to declare it dependencies, but you cannot guarantee that your dependency declaration is complete. If you forgot a dependency, then you have to separately install on your system, then the component may build and work correctly on your machine but failing on the end user's machine. So what happens is, when developers are using a package management system like RPM and they have to declare the dependencies, but it is not 100% guarantee that the dependency declaration is complete. Sometimes the developers forget to say to declare some dependency, and when you install this on the developer machine it might work, but when the package is going to get installed on the end user's system, then these undeclared dependencies might crop up, and we can say it will cause the failure of the application package to run on the end user machine. It might run on the developer's machine, but it may not work on the end user's machine, because what happens is, this undeclared dependency might not cause problem on the developer's machine, because that undeclared dependency, suppose there is a undeclared package, say there is two undeclared packages, somehow those two packages are already there on the developer machine, then the developer machine will not have a problem running that application, but when it will be installed by the end user on his system, those two packages might not be there which are undeclared, and then this the package that end user wanted to install and run, it will not run, because the two undeclared dependency packages are not there on his system. So this is how the issues come up in most of the package manager. But in NixOS those won't happen, because NixOS there is fixed dependencies. So if the dependencies are met on the developer's machine, those are going to be met on the end user also, and if the dependencies are not met on the developer's machine, the package won't build, and the same package of course will not be offered to the end user. So if it works on the end user machine, the same package and its dependencies will always work on the end user machine also. Nix ensures that the package dependencies specifications are complete and met. Under Nix, a build process will only find resources that have been declared explicitly as dependencies. There is no way it can build anything until everything it needs has been correctly declared. If it builds, you will know you have got a complete declaration. Once the build is complete, ongoing runtime dependencies are deleted automatically. So what happens is, when you are building a package, the runtime dependencies, the runtime packages that are required to build a certain package are detected automatically. So the packages are bought, you can build your package, and once the package is build is complete, the ongoing runtime dependencies are automatically deleted. Multi-user support. Starting with the version 0.11, Nix has a multi-user support. This means that the non-privileged users can securely install software. Each user can have a different profile, a set of packages in the Nix store that appear in the user's path. If a user installs a package that any other user has already installed in previously, that package won't be built and downloaded for a second time. At the same time, it is not possible for one user to inject Trojan horse into package that might be used by the other user. So what it wants to convey is that the same package, if it is installed by one user, then the package will appear in the user's path. Now if second user wants to install the same package, it won't be that required package won't be built or downloaded a second time. It will create a new path. So say user A has this particular package, say VLC media player has been installed by user A, and user B wants to install the VLC media package, then the system will not download and build the VLC media player package again. It will just, what it will do is, it will create a new path for the user B, and this VLC package files will be written in that path. So there will be two paths, two VLC media players. So the different paths will be there, and then the execution will occur whenever the user A wants to run the VLC media player. It will use the path that is been recorded in the system for the user A, and if the user B wants to use the VLC media player, it will use the path that is recorded for the user B. So two different paths will be there, but the package will be same. So it is not possible for one user to inject a Trojan horse into package that might be used by other users. So what happens is, if user A is a hacker and he wants to hack and install some virus or Trojan in the user B VLC media player, it won't be possible because the two paths are different and he won't have authorization for the path of the user B. So user A cannot interfere in user B's applications and user B cannot interfere in the user A's applications. So atomic upgrades and rollbacks. Since the package management operations never overwrite packages in the Nix store, but they just add new versions in different paths, they are atomic. So during a package upgrade, if no time window in which the package has some files from the old version and some files from the new version, which would be bad because the program might crash. So what happens in other package managers is that whenever you install some upgrade of any package, say the VLC media player package is being updated, so it might happen that the upgraded VLC media package might use some older files from the older versions and some new files from the updates. So it is a mix of new and old files. Some files of the package will be upgraded, some will be continued from the older versions. So sometimes this leads to an crash. So the program might crash if it is started after the update is done. But here in NixOS, the crash won't happen because the packages are not overwritten. The older versions continue to remain there in the system in the older paths, and the newer applications are installed in the newer path. So the path execution path will remain different and the application won't crash. So these are some commands to manage your Nix package manager and do system administration and some system installation and installation packages and all those kind of things, collection of garbage. So we will see this in the other video. So I have, I think, done the introduction to how the Nix package manager works. So I will now, I think, stop here, or what we can do is we will go further and read about, know about this basic package manager, and then I will stop the video here. From the next video onwards, I will show you how to do the upgrades, rollbacks of the Nix package manager, install some packages, uninstall some packages from the NixOS. Okay, so now we will continue with the basic package management. The main command for the basic package management is nix-env, that is the Nix environment. You can use it to install, upgrade or erase packages and to query what packages are installed for available for installation. In Nix, different users will have different views on the set of the installed applications. Views is nothing but the different paths to the install application. So to two users, user A and user B, will have different paths to the set of installed applications or packages. There will be lots of applications present on the system, possibly in many different versions, but the users can have a specific selection of those active, where active means that it appears in a directory in the user's path. Such a view of the set of installed applications is called user environment, which is just a directory tree consisting of system links to the files of the active applications. Components are installed from a set of Nix expressions that tell Nix how to build those packages, including, if necessary, their dependencies. This is a collection of Nix expression called Nix packages. Package collection that contains packages ranging from the basic development stuff such as GCC, glibc to the end user applications like Mozilla Firefox. Nix, however, is not tied to Nix package collection. You can write your own Nix expressions based on Nix packages or completely new ones. So what is Nix expression? Nix expression tells the Nix how to build the packages, including the dependencies. So all the things are declared here. So which package will have which dependencies, how it will be installed, it is all declared in the Nix expression for a particular package collection. So all the packages that are installed by the Nix package manager ranging from the development stuff like the GCC, glib to the end user application like Mozilla Firefox has a Nix expression. So there is a unique Nix expression for each of the packages that are going to be built and installed in a Nix environment or a Nix OS. So you can manually download the latest version of Nix packages from the GitHub NixOS Nix packages. However, it is more convenient to use the Nix packages channel since it makes it easy to stay up to date with the new versions of the Nix packages. Nix packages is automatically added to your list of subscribe channels when you install Nix. If it is not the case for some reason, you can add it. So with this, I will stop the video here. In the next videos, we will all check out how to check out the Nix channel that you are subscribed to. You can change the Nix channel, how to do it. You can view the set of available package in the Nix packages. All these things that are to be done from the terminal, we will do it in a series of videos from the next video onwards. So I will stop the video here. So in this video, we had just a introduction of how the Nix package management works, how the Nix package manager works, what are the Nix expressions, how the packages are installed in different file paths for the different users. All those things we have checked. So I will stop the video here. See you in the next video. Bye.